Welcome to this bonus lecture. You have learned classes, inheritance, and composition. Now, I want to show you the crown jewel of object-oriented programming, polymorphism. We will see how to treat different objects, like a standard LED and a LED blinker, as if they were the same type, allowing us to write incredibly flexible code. Polymorphism means many shapes. In our case, it means we can treat a LED blinker as if it were a simple LED. This is possible because LED blinker inherits from LED. By using pointers to the base class, we can create a collection that holds different types of LED behaviors in one place. To make polymorphism work, we use the virtual keyword in our LED header file. This tells the compiler that when we call a method like turtle, it should check if a more specific version exists in a child class like LED blinker, and use that one instead. Inside LED blinker.h, you update this line. And inside LED blinker.cpp, you update this line. We can create an array of LED pointers. We point the first element to a standard LED and the second to a LED blinker. Even though they are different classes, we store them in the same LED array. When we loop through them and call turtle, the standard LED simply flips its state, while the LED blinker uses its overridden logic. This approach is extremely powerful. Imagine you have a system with 10 different types of outputs. With polymorphism, you can put them all in one list and update them with a single loop. Your main program doesn't need to know the details of each object, it just knows that they all know how to respond to the same commands. You have now seen the true scale of object-oriented programming. From simple variables to polymorphic arrays, you have the tools to build world-class Arduino software. This concludes our bonus session and our entire course. Thank you for being an amazing student. Go forth and create something incredible.
Happy coding!